Hello, I'm Dave Brooks. I will be your host today as we explore through the topic of nuclear power. The mention of this topic may bring up many questions like, what does nuclear power do for us? Where does it come from? How does it work? How does it compare to other energy sources? And is it safe? All of this and more will be answered as we continue through this video. So let us start our journey through the subject of nuclear power. To begin, let's start with a little history lesson. Don't worry. Just a few facts to get us started before we hit the fun stuff. Now, as we look back into the history of this energy source, we come across this man.
Enrico Fermi, a U.S. immigrant from Italy who won the Nobel Prize in 1938 for being the first to ever create nuclear fission by irradiating uranium atoms with neutrons. Let me show you exactly what this means. Here is a uranium nucleus containing protons and neutrons. As a stray neutron collides with the nucleus, it splits into two smaller parts along with more stray neutrons that you see towards the top of your screen. These two smaller nuclei that are created in the collision weigh less than the initial nucleus. The mass that was lost was converted into energy. This is shown through Albert Einstein's formula, E equals mc squared. That is, energy produced equals the mass times the speed of light squared. This whole process of the splitting nucleus creating energy is called nuclear fission.
Now, after this important discovery, were many important events that happened in nuclear history.
In 1946, the Atomic Energy Act was passed by the Atomic Energy Commission. This was created in order to control nuclear energy development and explore peaceful uses of nuclear energy. Also in this very important year of 1946, the first nuclear chain reaction was achieved by the Soviet Union.
A chain reaction is when the stray neutrons from the first fission go on to cause more collisions. And this goes on to cause even more collisions and more nuclear fission. This causes for a lot of nuclear fission and a lot of power. And that is what we need to create lots of energy and electricity in our nuclear power.
After this important discovery, the first commercial nuclear power program came to be in 1954. It was announced by the Atomic Energy Commission to be a cooperative program between government and industry to develop nuclear power plants. In 1955, Arco, Idaho, with only a population of 1,000, became the first U.S. town powered by nuclear energy. The power was provided by an experimental reactor, Borax-3, at the Idaho National Energy Laboratory. In 1957, the first power to ever be generated from a commercial nuclear power plant was in Santa Susana, California. Also in 1957, the first full-scale nuclear power plant began service in Shippingport, Pennsylvania.
Then, in 1980, for the first time, nuclear energy generated more electricity than oil in the United States. Nuclear power then replaced hydropower as the second largest source of electricity in the United States after coal in 1984. Now, today, nuclear power provides almost 20% of the world's electricity. There are more than 100 nuclear power plants in the United States, which generate 69% of our non-carbon electricity. Now that you know a little bit about the history of nuclear power, let's get into how it works.
As we discussed earlier, nuclear power plants use nuclear fission in uranium to produce power. Uranium fuel pellets are very small. Just 8 of these pellets will power an average household for 1 year. These pellets are stacked together in metal tubes, and those tubes are bundled together. Several thousands of these bundles are placed in a large tank in the nuclear reactor.
Now, it took me a long time to draw all this, so I hope you pay attention. The uranium rods are placed here in the reactor. Now, as we learned earlier, nuclear fission in the uranium produces a lot of energy, which in turn produces a lot of heat, which heats up the water pumping in through here. This is a special kind of water that stays in liquid form even when at very high temperatures. So this water is heated up through nuclear fission, and it is sent to the steam condenser here. A new system of water is pumped into the steam condenser, and it is heated up by this first system of water. When it is heated up, this water is formed into steam, which rises up into this new system and comes down and spins this turbine. This turbine allows the generator to produce electricity, which is sent out to our homes and towns. Now the steam that turns this turbine comes down and it is cooled by yet another system of water from the cooling tower. This water is very cool and cools down the steam to condense into water liquid form again. The water is then pumped back into the steam condenser to start the system of heating and cooling and turning the turbine all over again. So here we have three systems of water. Water that is continually being heated, which in turn heats this new system of water into steam, and then this cool water, which turns the steam into liquid.
Now that you know how nuclear power plants work, I bet you're wondering if this is a good, clean, sufficient power source. The answer is yes. Some may compare it to solar and wind energy, but these sources are very impractical. They're far too expensive and insufficient. In order for these to produce a sufficient amount of energy, they must use tens of thousands of acres. Also, solar and wind energy are very expensive compared to nuclear power. Now, if we compare nuclear power to fossil fuels, we will find that nuclear power is much more sufficient. It takes 500 kilograms of coal to power the average household for 1 month. It only takes 3 grams of uranium to produce the same amount of electricity. Nuclear power is also much cleaner than fossil fuels. At fossil fuel plants, carbon dioxide is released into the air, causing pollution, acid rain, and global warming. When some people think of nuclear waste, they think of what they have seen on TV and in Simpsons episodes. Well, I will tell you that the nuclear waste is not green goo dumped into lakes creating mutated animals. Nuclear waste is just the used up bundles of uranium stored in extremely strong metal cases. These really strong cases allow for absolutely no environmental risk. Also, against popular belief, nuclear power is very safe. More people will die while mining, drilling, and transporting fossil fuels. There has been a widely known accident in the Soviet Union at the Chernobyl nuclear power plant. This accident could never happen here in the United States. We have many safety precautions that stop this exact event from happening. Nuclear power is very safe.
I hope this video has taught you all that you've wanted to know about nuclear power, the facts, the history, and how it works. I hope it has also enlightened you about how great nuclear power is. Against common misconceptions, it is clean, safe, and sufficient. Nuclear power should be used in the US and all around the world. It is a great benefit to mankind. So I'm Dave Brooks telling you to embrace the power. Nuclear power.